you for joining Group 3 for the Practical Cryptology final presentation. Group 3 members are Jonathan Luzader, Vinicio Dominguez Imbut Garip, and Nancy Gaillard. In this section, I'll introduce the current problem which we're addressing with urgency. I'll provide a background to justify our concerns and propose a solution. I'll also inform you of the enterprise IT architecture, the stakeholders, risk and mitigation plan, and encryption zones. The enterprise uses a unified communication systems to provide employees with additional features for voice over IP. We maintain the unified communication platform in-house. The platform is comprised of a soft switch, referred to as Talk to Me, and a native application referred to as Right Now. The vendor released an end-of-life notice on the Right Now application. This means the manufacturer will no longer support the provisioning software. It raises concerns, particularly the vendor will no longer provide security patches or bug fixes. It introduces risks, vulnerabilities to hackers and malware, threatening data confidentiality, integrity, authenticity, and non-repudiation. Exposure of private, personal information of our employees, customers, and potential clients, as well as the confidentiality of company information and security of our IT systems. Not to mention the loss of customer trust, revenue, profits, and investors, as well as increased costs to run the business due to potential fines for violation of compliance. Although the vendors chosen to end of service and end of life their application for the soft switch, it doesn't mean that the software is no longer available. It just means that it poses a threat because it's no longer going to be supported by the vendor, and therefore we ought not use it. However, they have left an application programming interface for which we can integrate data. That would be using a third-party solution, and that's the whole emphasis of this project. What that does is it enables us to continue to use the soft switch hardware, and in that regard, we've gone ahead and sourced vendors, and through a process analyzing alternatives, the offerings of those vendors, we selected a third-party vendor whose solution is referred to as Express. And so as the CIO, or someone in that office, I need to implement a replacement for the voice provisioning application so that it can be securely integrated with legacy back office systems. Security in cryptography and software security are very different. Listed in this table, we have common threats associated with unified communications solutions. Understanding those potential risks enables the Information Security Office to protect against them. Some of the common threats include having a need to understand potential risks, repercussions, and methods of protecting assets to ensure that additional threats or something more egregious is not encountered. Allow me to introduce you to John. John, he's on the left of the screen. He's a new employee. He just received his badge and is ready to onboard. As a new employee, John serves as an example for a typical enterprise user and how they use the UCC solution. On the right-hand side of the screen, you'll see IT administrators. These IT admins, they interface the soft switch to configure user profiles and extensions for location moves, to add new users or new profiles, to manage changes, or to execute deletions. So going forward, I will reference the provisioning activities as MACD. MACD stands for Move, Add, Change, and Delete. To provide the assurances of confidentiality and authenticity of data exchange between the client and server and between servers, we established a secure channel to protect internet-based communications using TLS 1.3. The security goal is to prevent a man-in-the-middle attack. To provide assurance of confidentiality of data exchange between an on-net client and server, we assure domain and organization validity using SSL certificates. We also provide assurance of data confidentiality, integrity, authenticity, and non-repudiation by implementing network layer encryption with IPsec virtual private network clients. IPsec supports triple data encryption standards, or triple DES, and advanced encryption standards, AES, for data confidentiality, and SHA-2 for integrity protection. To provide assurance of confidentiality and integrity of data at rest, transparent data encryption, or TDE, and file key management plugins on the Maria database server that we're going to be using will be implemented, and that's for data at rest encryption. The solution: management of encryption keys and encryption and decryption of data, data tables, temporary files, binary logs, and compressing data, and then encrypting it. So it's to protect the privacy of data and prevent data breaches, to support the use of multiple encryption keys and key rotation, as well as database table encryption and decryption, and not to mention the need to meet data protection regulations. Firewalls will be added to the network to add perimeter security, and security policies will define compliance standards for the network to ensure business operates in scope and within legal regulations. Vigilance through training will provide ethics and compliance to our staff in the best way that we can, and that's through the Ethics and Compliance Office. And they'll ensure that security policies can be referenced by employees, and HR will maintain a schedule as well as tracking employee security training in the corporate LMS system or learning management system, as well as on the employee's transcript. Quarterly maintenance routines and audits will ensure that we are proficient with our processes and familiar with executing those processes to an optimal level, as well as ensuring systems fail over as they're expected, and to make sure that employees remain familiar with locating security processes as well as policies. In Section 2, we'll go over the system components as well as the encryption protocols selected for implementation. Express runs on a Linux 8.1 operating system, and within the Linux there's a database. So right off the bat there's areas that need to be encrypted. So for one, Linux is accessible over the internet, and so client PCs, they'll access Express via a web-based interface. And so one of the things that I would do for encryption is to secure that connection. Additionally, the database that resides within Linux, that also has to ensure that data remains secure when at rest, when in motion, and when in use. Let's see. So one of the things that would probably be established is an SSL certificate. It indicates a secure session is established between the user and the browser using a secure socket layer protocol. This secure connection, it can't be established without an SSL certificate. And so the SSL certificate, it digitally connects the company's information with a cryptic key. Additionally, there has to be some management, remote management of the system. And so SSH can be used for that, remote management, and for file transfers, or even to put up a virtual private network. ASA SSH version 2 could be used, and with that, the key exchanges on port 14. Perhaps it's worth going over how SSL certificates work. And so in this diagram, you'll see that the process begins with the client messaging the web server, and the message actually initiates the SSL communication. Then the browser requests that the web server identify itself. The web server sends the client a copy of its encrypted SSL certificate. And then the client message, well, it's either one of two messages. One would be that the client's browser checks to see whether or not it trusts the SSL certificate. If it does, then the client's browser sends a message back to the web server with an encryption key. And in this particular case, as you can see in the diagram, it's a public key. So the other message that can occur is an error message in which this certificate is not good, so then the communication fails. All right, so now the server sends an acknowledgement. So the web server sends back a digital signed acknowledgement to start an SSL encryption session. The private key is used digitally to sign the certificate signing request. And then later to secure the verified connection to the server. So the server decrypts the key and delivers the encrypted content with the key to the client. With the SSL certificate and successful handshake between the client and the web server, the client, in this particular case, we'll say it's IT personnel. They'll browse and they'll access Express in order to do their MACDs. The SSL handshake also takes place between the Express server and the soft switch, which is in that particular case, it establishes a secure connection as well. And we're going to go on to more of that next. SSL, an asymmetric encryption, has many benefits, as you can see from this slide. It utilizes a private and a public key in its encryption. And the reason really why I selected SSL is to emphasize the point that the client needs to establish a secure connection to Express. Likewise, Express, as it behaves as a client, will need to ensure that it has a secure connection to the soft switch. That being said, there are some disadvantages to SSL. F5 indicates that over 80% of web pages they load with SSL and TLS encryption. However, they feel as though there's still an increasing concern, and that's because attackers use encryption to hide malicious payloads. So essentially, what goes on is that they will host a website that looks like an authentic website and it isn't, and that's how they go about stealing information, critical information at that. Following the data, let's move on between the Express server and the soft switch. To ensure that we have established a secure tunnel between both servers, I've selected Transport Layer Security Protocol, or TLS 1.3. 1.3 is the most current version. And although it's referencing the transport protocol, it has nothing to do with the transport layer. So I just wanted to add that as a caveat. What I hope to gain out of TLS in this particular instance, it would be to protect the connections between the two servers, as I mentioned, the web server that Express is hosted on, and the soft switch. TLS, some of its characteristics is that it's operable with all applications. By implementing the TLS protocol, I hope to prevent man-in-the-middle attacks. How, you might ask? By having server authentication using certificates and trusted certificate authorities. So TLS is made up of a suite of protocols, mainly to figure out how to transmit data and which data needs to transmit. The certificate validation step returns a handshake back to the client with a key, and the client's browser knows to complete the verification because it is signaled by a trusted third party. That third party is the certificate authority. The other thing about TLS is that it uses zero padding, so it adds extra zeros to the plain text to inflate the ciphertext size. The Maria database at rest encryption, it requires the use of a key management as well as an encryption plugin. And these plugins are responsible both for management of encryption keys and for the actual encryption and decryption of data. Having tables encrypted makes it almost impossible for someone to access or steal hard disks. as well as gaining access to the original data. So MariaDB, it uses data at rest encryption. We're using MariaDB 10.1.4 that has that capability, and the functionality of transparent data encryption, or TDE.
Thank you, Nancy. Here I'm going to talk about the technology selection that we use for this specific system. So we're going to see here the comparative analysis of each core system security component, the interoperability, deployability, and maintenance of each one of the components, and provide detailed recommendations of why we choose this solution for the system. So the components that are on this system, as we can see here, one of them is the main server, which will have all the components necessary for the application to run. Also, we included a redundancy server just in case the main server failed, and uh, that way we always have operations running. An API that it's a component of the system that makes the communication possible between the different IT components inside the system, and a web server that stores data and makes possible the use of the system over a web browser. In this specific case, the web server is going to permit users to connect remotely or locally to their, in this case, to their extension, to their phone extension via a web browser. As we can see here, for our technology deployment, we chose firewalls. Why do we do this? Since one, we're going to have users connecting from outside the network. This will give external users the ability to connect remotely through a VPN to the local network to use the app, and while also giving the users inspection and protection the traffic from the traffic that is coming from outside to the inside network. We also included a second firewall, which, as we're going to see ahead on the next slide, that second firewall inspects all the traffic, and in case the firewall number one doesn't detect a packet that it should have, the second firewall will serve as a second detection mechanism to protect the inside network. As we can see here, is a diagram of uh, the Talk to Me system that we are exposing. So as we can see here, the external users are going to connect uh, to the system via the number one firewall that I mentioned before. Um, while this firewall will be protecting those external users to the connection inside the DMZ. And then, as we can see here, there's also a connection between the system and the internal users. And as I explained before, here is a secondary firewall which protects the internal users just in case this firewall does not detect any threat. Well, the second firewall will be there to protect and detect. And as we can see here, this little router, what this is not actually a router. This is a SIP protocol device that what it does, it manages all the incoming and outbound SIP requests. Since this is at the end, this is a voice over IP system, so this device will be in charge of channeling and managing all those SIP requests. Security policies. So the objectives of an IT security policy is the preservation of confidentiality, integrity, and availability of systems and information used by an organization members. This is what we refer as the CIA triad. So what does what are the three elements that compose the CIA triad? So imagine a triangle. In each corner we have uh, one of the corner is confidentiality. So what does this means? Confidentiality involves the protection of all the assets and equipments that are inside and outside the network. What are we protecting right now? Well, first we're protecting uh, the system inside the network while also protecting the external users that are connecting to the network. Um, as I explained before, in this case, we're using firewalls in each point of entry for the internal and external users to protect traffic and inspect traffic. The second concept is integrity. What does integrity ensures? It ensures that only the users that are authorized to use the system can make changes to components and can use the system. Only admins with proper permissions will be able to create modified users from the system, and only the users that are authorized to use the system as a basic users to make phone calls and receive calls will have different permissions as admins. Also, we have this third and last component of the CIA triad, which is availability. So, what availability means is that authorized users have access to all times. In simple words, it's just that the system is always up and running, so the people or the external users and internal users can use the system and uh, and do their function as efficient as possible. Um, by this, we have redundancy systems put in place before and internet connection, so user will always have a connection to the system. Data retention. So here, this system will have a data retention policy uh, that will retain all the call logs, everything that people, users are doing inside the system for security purpose and to comply with the law. So data retention policy are a set of rules that an organization established to maintain data for a certain amount of time to comply with the local government compliance. The system will always have data stored and will always organize it in a way that it can be easily searchable and disposable. First of all, why easily searchable? Because if we have if there's an easy way to search for the information, that means if a local government asks us for us different type of call logs or different calls, we can easily search those content in the database instead of being a headache. And also, why is the disposable term? Disposing of the information is really important since um, we don't want to have information that we shouldn't have after the period of time, because having more information than we should means that we could be that the system or the enterprise could be in trouble because of law regulations or whatever it is stored. And there's a law, the on the U.S. government under the Stored Communications Act, SCA, says that data must be stored and preserved for up to 180 days. So this means that from a company perspective, uh, just after the 180 days, if data is not necessary, it should be securely disposed. Just so that way, that won't show us a liability for the enterprise. Thank you for hearing me out. And next, Jonathan.
Thanks, Vinny. My name is Jonathan Luzader, and I'll be walking us through our project team's project management approach, as well as cover the modernization roadmap along with some of the elements of our cost model. Results are still preliminary, and we appreciate your feedback and insight as we continue with the Talk to Me initiative to modernize how our organization implements voice over IP and benefits from 21st century technology. Due to the nature of the project involving cyber-physical systems, as well as systems with diverse software and hardware components from multiple vendors, we recommend using the Scaled Agile framework to integrate and deliver the VoIP system. In addition, to SAFe, we recommend using a bimodal or hybrid software development lifecycle that invests more time up front in reducing risk by articulating ideal target state architectures, interim state architectures, as well as the intent of the overall solution. As discussed, core to our project management methodology is a bimodal hybrid agile approach, and to ensure that we are not reinventing the wheel, we're looking to industry and other government agencies for models that have demonstrated success in the past. The main graphic depicted shows the Department of Veterans Affairs VIP methodology, which is a hybrid approach involving upfront project planning with an iterative product phase that produces product builds at maximum 3-month intervals, with no limits on how often builds can be produced within those intervals. So this is an important component, as it allows all organizations and teams involved with the product from a qualification perspective, including security, to be incorporated in the product development and implementation process. This is opposed to their involvement either being an afterthought or at the tail end of the implementation when it's already going to be too late to fix critical defects. So during the product phase, we'll be adapting and tailoring the Scaled Agile framework that's depicted below, which is a popular industry framework for instantiating Agile at the team level and then coordinating those teams at scale across the organization to deliver the final product. So overall, this approach reduces the length of feedback cycles from business to technology, and it serves as an overall way to reduce risk and improve the time to market, as well as provides for rapid response mechanisms to critical issues found in production. In addition, an iterative model provides early validation of metric baselines, and it allows organizations to essentially predictively model future iterations and determine from a leading indicators perspective whether our delivery is on track or not based on the tangible progress that has been made on the ground. So, this will also provide sufficient lead time to course correct and make adjustments. Next up is our modernization roadmap, which details the lifecycle phases depicted on the previous graphic, and consists of 4 key phases, right? So you have initiation, project, product, and the sustainment phase. As you can see on the left, our stakeholder organizations are listed out and consist of the business office, which is responsible for serving as voice of the customer, the project management office, who essentially will be providing oversight, risk analysis, schedule analysis, etc. We have operations, IT development, service quality, and security. We're all domain-specific service providers that will play a key role throughout this implementation over a multi-year period, and will be vital for our team to ensure that as an organization we can collaborate and ensure alignment, and make sure that all of our partners are part of the process. So this jumps into our next part, talking about change management. It's obviously very vital with a large program. What happens when defects are found in production? What happens when security issues are found in the planning or product phase? How are these changes managed and made visible? How do we maintain transparency? So our change management process makes that clear, and we'll utilize our hybrid approach to ensure that we do get that traceability from the big ticket changes down to implementation and the testing activities going on the ground. In the Scaled Agile framework, stakeholders play a vital role in the process and are brought along throughout the implementation. to help ensure that they have a voice and can support and advise teams where they may need, where the teams may need their insights or their help. So, during the product phase, we'll be conducting joint in-person planning sessions, essentially each quarter, and that helps define the business objectives from the business's perspective, and then it ensures that the technology teams involved are there to make those objectives a reality and that those objectives make sense. So this is done with business and technology personnel that we actually bring together in the same room for 2 to 3 days. So in addition, through that period, we're doing risk identification. We're talking about not just dependencies, but mapping those across the teams and making sure that teams have awareness of what's required of them. Security is another aspect of that. So at what point during this process do we need to have security scanning, code scanning, threat identification, those kinds of things, and how does that play into the rest of this whole process? So that wraps up stakeholder management, and we'll go ahead and jump into cost analysis. So we won't spend too much time here, except to reference that based on current projections and our assumptions, we're projecting a life cycle cost estimate of a cost savings of $166 million over the next 5 years. Jumping into expenses. So our largest expenses, as you can imagine, will be contract direct labor, with a total projected cost of $152 million over a 5-year period. Based on our cost model, we're projecting an internal rate of return of about 9%, which suggests there's strong financial justification for this modernization effort and greenlighting this project. Please forward any questions you may have, and our lifecycle cost estimate analysts will get back to you as soon as possible. Thank you again for your time. Thanks to our other presenters, Vinny and Nancy, and we're looking forward to your feedback, and have a great afternoon.